the last ever one, the last time I'm ever going to do this again. We're going to understand the AWS Step Functions service. Step Functions is a web service that enables you to coordinate the components of distributed applications and microservices using visual workflows. You'll build an application from individual components that each performs a discrete function or task, allowing you to scale and change applications quickly. Step functions provide a reliable way to coordinate components and step through the functions of your application. Step functions provide a graphical console for visualizing the components of your application in a series of steps. It automatically triggers and tracks each step and retries when there are errors, so that your application executes in order and as expected every time. Step functions log the state of each step, so that when things do go wrong, you can diagnose and debug problems quickly. So it manages the operations of the underlying infrastructure and ensures that the application is available at any scale. With step functions, you're able to easily coordinate complex processes comprised of different tasks. For example, if you have an image that you need to convert into multiple formats and scale it into different resolutions and analyze it with recognition, you can split this process into single and automatic tasks with functions and execute them simultaneously. After that, you can have another function that checks the result. Without this service, you'll have to coordinate every function yourself and manage every kind of error in the steps of the complex process. In the screenshot, you'll see the graph as demonstrated the example below. Cool. So step functions are useful for breaking down complex processes into smaller, easier tasks. If you have a real-world example, you'll build the solution using step functions. We'll write a small atomic reusable Lambda function. These can be reused in several places, for example within different flows, as an endpoint behind the API gateway, and as a single function in response to an event. The details of the specific scenario are as follows. A game has been developed, it uses Lambda, DynamoDB, and other services. A component of the game is missing that handles the housekeeping task when a player completes a level or the entire game. This process consists of the following different tasks. We're going to generate a report for the last completed level. If the user ends a level, we're going to update the completed levels table. If the user ends the entire game, we're going to update the completed game table. We're going to add a log metric within CloudWatch. To accomplish this, you need to create a state machine. All state machines in AWS are defined using the Amazon States language. This language uses the JavaScript object notation to describe state machines declaratively. In the console, we're going to build the workflow and visualize it through a flowchart. JSON necessary to create the chart is shown below, and you'll analyze it in greater detail in the following steps. We can also find it here. Cool, so there's the code if anyone cares.
Web link.
Alright. So we have 3 tasks to perform: to generate the report, update a table, and log the metric to CloudWatch. We have a JSON snippet that defines a parallel task. JSON template defines a flow comprised between different fields, and each one defines a different aspect of the flow that we're building. The start at field defines the first state where the flow will begin, and the state objects contain definitions of the reachable states. Cool. The Lambda function that will utilize an S3 bucket. Before creating the Lambda function, you need to know what S3 bucket to use. We've already created one for you, and we'll navigate to the S3 console and read the bucket name. It should be something like this. Be sure to copy the bucket name. So let's do that first. Let's go S3. Our bucket name. Right, and then we can go over to Lambda. I'm going to create the function. Author from scratch. It has to be called generate report. We're going to use Python 12, whatever the latest one is. Under permissions, we're going to change the default role to one that can run functions. Alright, so we're going to create the function, we're going to navigate to the code, and we're going to enter the following. Alright, we need to put in the bucket name. So code will look like that. Be aware that the lab, you're hard coding the bucket name for the sake of convenience, otherwise we would go and fetch it as best practice. You'd probably pull it from the parameter store, which is a good way to decouple configuration from code. Right, so we can deploy it. It's not asking us to test it, so that's all we have to do. At the end of the lab, you'll see when we start the execution, and we'll provide the start event. Cool. Right, so our first checkpoint. Have we created the desired number of Lambda functions? There we go. Right, the other branch of the parallel task, we need to update the DynamoDB tables. In many scenarios, the flow is dependent upon a choice. We'll have to fulfill this requirement. Step functions provide us choice step. The second branch starts with the update DB task and the type is a choice. When we arrive at this flow, a choice will be made whether to allow the step function to make the choice. The step that gets executed is based upon that choice. The choices field on line 6. So there we're going to look at the variables and see if the string equals latest last level. So there's a number of string comparisons that get made that dictate what the choice is. Cool. Right, so if we navigate to the functions page of Lambda, we'll create a new function. This one's going to be called ends simple level. You can use the latest version of Python again. Change the role to one that can run functions. And then this time we're going to use this code. Thing to update there. So this code will call the update item API on the completed level table, and it will return the event argument it receives. As mentioned previously, the result of each function is very important because it's what the next function will receive as the start of its flow. So we deploy this. Back to functions. We're going to repeat the process again. This time we're going to create another function. This is when they end the last level. Python 3.12. Permission, one that can run roll. And then this time code is that. We're going to update completed game with the user ID and their score. We deploy that. Another checkpoint. Right, the last function that we need to create is the simplest one. It updates the completed level metric on CloudWatch. So if we navigate to functions once more, and we create a new one. This one has to be called metric. Python, change the execution role. And the code for this one is as follows. Photo for client CloudWatch, complete level. We're going to push the new metric into CloudWatch. So we'll deploy that. Cool. So now we've got all 4 Lambda functions required for the state machine. Go to the console and we'll search for step functions. So I'm going to put it all together. Right, get started. Let's get rid of that. Right, we're going to let's not do that. There we go, that's what we want. So brand new state machine, we're going to create the state machine. We're going to ensure blank is selected. I'm going to select the code. Got some default code so that we can just paste that in and it will generate the state machine. So center it. So this code is dictating what the flow is of the state machine. So you have a start, parallel task. It's going to generate the report. We can update the database table based on the choice, whether it was the latest one or just a normal one. Right, we're going to replace each occurrence of account ID in the JSON template with my account ID. If I can find it. Account ID, there it is. So there we go, so that's set up right. That's all the student bit. Okay, that's better. So now the graph isn't freaking out. If we go over to config, now we can give the state machine a name, so we've got to call it complete level flow. Under permissions, we need to give it a role, state service role. This role is the service role assumed by the step function service. The permission it has is the service needs to run the Lambda invoke function permission. Cool, so we can create the state machine. Placed on a page that shows the details of the state machine, you see a green notification at the top telling you that the state machine was created successfully. We can now start an execution. You see the name. Let's paste the following into here. Alright, so this, it's okay to leave the name of the random one that AWS generates. We don't need to worry about that. So we've got, in the JSON, all the parameters for the execution is present. This includes information about the user playing the game, what level they finished, and the related scores. Start the execution. There we go, we get the execution has begun. And it's done. In the upper section you'll see the overall execution details. The boxes on the left show the flowchart that will indicate the state of the process of the step detail. You can expand the input, output and exception sections to see the details of the status of the task. So we can see like what all the outcomes are. Right, at the bottom of the page is the list of all the transactions and events. Observe the list of all the transaction events and expand and collapse each transaction by clicking on the arrow adjacent to the ID of the number. Every call is logged to CloudWatch as well. You can now play around with the service, either creating a state machine or creating another one of your own. If you see any Lambda functions transition fail in the events, check that the function has been deployed using the Lambda console. Right, that's it. So we just need to run this check. So, did the step functions execution succeed? Did we watched it happen? And is that all we've got? Yeah, that's it. That is the last final